Welcome and hello. This is a video exercise in HEC ResSim, and in this exercise, I'm going to be talking about state variables. All right, we're going to go ahead and do an exercise with state variables. I'll show you how they work. All right, so what I have on the screen here is a HEC ResSim instance. We're going to start by going File, New Watershed. If you don't see that option, make sure you are in the Watershed Setup module here in the top left of the screen. Okay, so File, New Watershed. Then I'm going to give the watershed a name, and then select the location that you want that watershed directory to be created in, and open. Okay. And then select your units and then the time zone and apply. Okay, okay, and okay. All right, so our watershed has been created here. Let's begin by sketching out a stream alignment. So I'm going to click the stream alignment tool, hold down control, and then just continue holding down control as I click around, and then go ahead and let go of control before your final click and give the stream a name. Stream 1 works fine. Okay. When you're sketching out the stream, make sure to go upstream to downstream. So start on the upstream end. Next, I'm going to click the computation point tool and then hold down control and click on my stream alignment, and then I'll call it CP1. All right, next I'll select the reservoir and hold down the control. Single left click on the upstream end of the reservoir pool, and then uh, let go of control, click again. I'll call that reservoir 1. Okay. And then computation point tool one last time. Let's add one downstream of the reservoir and call that CP4. All right, watershed configuration editor. I'm going to go configuration new. Then I'll call this config 1. And set a time step, which is not really used. Apply and OK. All right, so that's all we need to do in the watershed setup module. Make sure to go File, Save Watershed. All right, so let's then switch the reservoir network module and then go Network, New. Here we're going to create our network. I'll just call it Network 1. And that's going to be based on configuration 1, which we just saved. So then New. And then that brings in my reservoir and my junctions. And then I'm going to click this reach tool here on the left, and then hold down control, click on the upstream end, the upstream junction, let go of control, click again on the next adjacent downstream junction, and then give that reach a name. I'll do that for this downstream reach as well. All right, I'm going to click the junction tool and assign an inflow to the upstream junction, CP1 here. So I'm going to right click, edit junction properties, then select this local flow tab. And then in the first line here, I'll just say inflow to CP1 and then a factor of 1 and apply. Okay. Okay, so let's go ahead and define this particular inflow. Right now, we just told the alternative editor that this junction has an inflow and that it needs to be assigned. So let's go ahead and create it. HEC DSS view is the first option here off the tools menu. So go ahead and select that. Then let's go ahead and file new. And I'm just going to call this file data. Data.dss was created. It's right here. Then here's the full file path. All right, so let's go ahead and go data entry, manual time series. For this simulation and this exercise, we'll use the month of July 2024 as an example. So let me just type in the path name parts here. I'll just be generic and say project, location, flow. If you actually had a project name or a basin or a river, you type that in A. B would be the location in that basin or on that river, and so on. And then for part F, this is user defined. I'll just call it 2K tilde because the flow is going to be sort of oscillating around 2000 CFS. I mentioned it was July, so I'll go ahead and go July 2024. The first hour is the first time step. And then the units will be CFS. All right. And then instantaneous value type is fine. Okay, I just went over to Excel and copied some values onto my clipboard. So I'm going to go paste, paste. There we go. And then now you see those values pasted in here for all 744 hours of a 31-day month. So I'll click save, and then I'll show you what that looks like. I'm going to click the record that we just created. This is a time series data set in DSS. And if I click this plot tool here, you can see this is going to be our inflow for the simulation. All right, so we'll be back to that in just a moment. I'm going to close DSS view and then let's click the reservoir tool. I'm still in the reservoir network module here in ResSim. So I'm going to zoom in. Yeah, click the reservoir tool, right click, edit reservoir properties. And then first I like to rename the dam to just dam. Now the pool, click the pool, and then you can type in or paste in data for the elevation and storage and area relationship within that reservoir pool. The top elevation is 1500, so I'm going to come over here to the dam and type in 1500 for the top elevation, and I'll just make up a length. We're not going to have overtopping, so that's somewhat insignificant. Add controlled outlet, and then I'm going to paste in data here. You can type it in, paste it in, and I have this data saved. So we have an invert 1400 and then a top elevation of 1500 with the corresponding max capacity flows. I'm going to increase the number of gates from 1 to 3. All right. So we're going to leave all the other settings here the same. This isn't the focus of the exercise, but I do need to set up this part of ResSim to get the model to work. So we'll go ahead and click apply here. And then over in the operations tab, we're going to go operations new. Here we're setting up an operation set. So I'll just call it OS1. Okay. It gives me the 3 default zones: flood control, conservation, and inactive. I'm just going to type in constant water surface elevations for all year for these 3 and click apply. Just because, again, this isn't the focus of the exercise, but we do need this data in here. I'll say 1400 is the top of the inactive zone. Okay, so if I double click on the thumbnail plot, it shows a little bit larger here with our 3 different zones. This is inactive, conservation, flood control, and then above 1500, it would just be air. There's no holding back the water that high. All right, so let's go ahead and create an alternative. We're going to go alternative new. I'm going to type in alt 1. This is just going to be our base case. So I'll click OK. Our time step will be 1 hour, and I'll leave all the other settings just as they are. Operations, we'll give the operation set 1 selected. Look back, we're going to use the 1480 guide curve elevation, which is the top of the conservation zone as our starting look back elevation for the pool. And then our look back release, I'll just say is 2000 because that's the average value, and that's the actual value that the time series for inflow CP1 begins at. And here's the time series I need to assign. So I'm going to select this first record here and then click select DSS path. Now I'm going to open up that data.dss file, which is right here, saved inside the watershed directory, and I'll click OK. Next, I'll select that record. Then I click this set path name button, and then that populated the record here in my alternative and made that reference. All right, alternative, save. Then we can close the alternative. I'm going to save the network. Okay, so first we're just going to push water through the reservoir, and then after that, we're going to set up a trial and get to work on those state variables. All right, so let's switch over to module simulation, and we need to create a simulation. So we'll call it simulation 1. July 2024, we'll be running this simulation. And then actually, let's start the simulation at the 2nd hour. The look back will be the 1st hour of the month. End date will be the 31st of July, and that will be the last hour of the month. All right, so I'll select the Alt 1 alternative down here by checking this checkbox and then click OK. All right, so our network popped into the main view of the page here, and we have the simulation created over on the right in the simulation tree. We are ready to rock and roll. So right click, compute, and then that ran. Looks like it ran fine. And then what I'm going to do is just right click, plot, and take a look at the plot. This is pretty much as expected. What we have here in the top plot is the water surface elevation maintains a constant 1480 for the entire month. And then the bottom plot here shows the flow versus time. So here is the inflow, and the outflow is exactly the same thing. All right. So what we want to do now with state variables is to create a couple state variables to keep track of really almost anything you can think of regarding the reservoir operations and systems. And this is actually a fairly simple scenario, except for the inflows a little wild. What I want to do is create state variables that keeps track of which time steps have an inflow above 2200 and have been rising for the last 4 hours, the last four time steps. And then I want to do the opposite and keep track of which time periods have an inflow that are less than 1800 and have been decreasing for the last four time periods or 4 hours. So we'll do that using a Jython script and state variables, and we will write that data to a DSS time series dataset. All right, so that's the roadmap for what we're doing in the rest of the episode, in the rest of the exercise. So I'm going to close that. Then I'm going to go over to edit and state variables. Actually, hold on. No, I said I would make a trial. So let's go alternative, new trial. And then I'm just going to say state variables for lack of a better name. And then right click, edit run. So I'm not going to modify the alternative. This is just going to be for the trial. So click on state variables, and this will open up our dialog box to modify state variables. There it is. Okay, I got my window resized here, and I'm going to start by going state variables, new, and I have it copied onto my clipboard. So I'm just going to paste. It's going to be called inflow high and rising binary. The value is just going to be 0 or 1. So that's why I ended it with binary. And the actual description is going to be something like this. When the inflow is above 2200 CFS and has been rising for the past 4 hours, true if one if true, and then 0 if false. Okay, so that's my description. I'll click OK. The parameter name, I will just say the same thing. This is going to be in all caps in part C of the data series, the data files that are created during the compute. So this is a good one to remember. And then the parameter, this is going to be unitless. So I'm just going to call it count because it's going to be 0 or 1. All right, now Jython script versus scriptless. This is going to be a Jython script. So we're going to write our code inside the three tabs here: initialization, main, and cleanup. So what I want to do is start by creating a print statement just to say, so I can track the variables through the console log, which may be a good idea for anyone who's new to the program. So I want to show you what I would do in that situation. I'm in the initialization tab, which means this is the script that's going to run one time before the main compute. And I'm just going to go ahead and say something simple, like I'm going to give a couple new lines, and then I'll just say start console log output, and then maybe one more new line. All right, so that's all I'm going to do there. And then state variable, save. Next, I'm going to go over to the main tab here. So this is the initialization tab. Here's the main tab. The cleanup tab, I don't think we need to use here. Now this is the main tab, and this runs once every time step of the compute. And then here is where we add our code. It tells us this is where I'm supposed to type. So I'm going to start by just saying, I need to print the time and date. Print date and time, and then also the step. So I want to get the step. I'm going to say step equals, I have a number of APIs. Here are the classes, and then inside I can expand by clicking the plus symbol and then getting the methods. And then the step, I believe, is inside time series. And then, hold on, no, it's not. I think it might be in runtime step. There it is, get step. Okay. So click that get step method and then insert into script. I believe you can also double click. And then that's all I have to do there. So that'll just be an incrementing integer, 1, 2, 3, 4, 5. And then the date time is going to be, I need to get the HEC time first. Oh, here it is. Get HEC time. Okay. The parameter from the HEC time that I want, I believe, is in the runtime class time series. HEC time. Okay. Yeah, HEC time. So it was in the HEC time class, and then here's the date. Here's date and time. All right. So dot, and then I can double click or just insert into script. All right, so I have my step, I have my date time. Now I want to just print that out to the console log just so I can make sure things are working correct. So I'll go ahead and say print 1, 2, 3, 4 spaces, step equals step. And then I'll do the same thing for the date and time variable. All right. Let's go ahead and run that and just see. It's not going to change the computation, but I do want to make sure that I'm got the right output started here to the console log. Then we'll actually start grabbing the data we want with that inflow and write in the real Jython script. I'm going to go save here. I'm just going to pull this over to the side here so I can grab it later. One thing I want to do before running this trial one with the script variables is to go tools and then console log. And then I'll put this over here on my screen. And then I'm going to scroll to the very bottom so that after I run it, I should be able to just scroll down and see the new output. All right, so state variables and compute, and that ran. Cool. Now let's go over here to the console log, and I'm going to scroll down a little bit more. Okay, cool. So here is the start of the console log, and then I'm not seeing anything. Oh, I think I know what I forgot to do. So I need to tell ResSim to explicitly run this Jython script. The initialization ran, but over here I need to check this checkbox that says compute as a post process. So I'll do that. And then state variables save. Okay, I think that's what I want. Let me go ahead and scroll to the bottom of the console log and then right click compute again, close. And then over here, okay, yes, that had to work. Much more output, I can tell. All right, so step 2, 3, 4, 5, and then we have the date time. It starts at 3 o'clock, 4 o'clock, 5 o'clock, and so on. Remember, the look back period is the first hour. And then this would actually be, let's see, we might be off an hour, but I'm not going to sweat that. All right, let's go ahead and actually write something more interesting. I'm going to add one more print to the bottom here from one more line to separate those time steps. All right, next I want to go ahead and add the inflow. So I'm going to grab the inflow time series. I'll just say this is inflow time series equals. Now I'm going to head over to the time series and then model variables. I'll expand that, click on reservoir 1, and then the flow in right here is what I want. So I double click that. I got my flow in. Remember, this is a time series, and if I want to extract just one value, then I can get the current value, use that method. So I'll say inflow equals, and then inflow time series dot, let me head over and grab that method. It's going to be time series, and then get current value. Here it is, I believe. Let me just expand. Yes, that's it. Okay, so boom, double click, and I'm good. For this parameter here, I need to paste in the time series current runtime step. Okay, and I copied that and I pasted it. All right, so that looks good. Let's go ahead and just print that out. In fact, let's add all of our print statements to the bottom. So I'm going to just move this. Paste, paste. It might not be a bad idea to click this compile script button. Okay, so that says it's successful. I'm going to go ahead and save. And then on the console log, I'm going to scroll to the very bottom, move this to the side, right click and compute on my trial. Okay, close. Let's scroll down and see if the inflows appear now. And they do. And we got that extra space there as well. So it's a little bit easier to read. 1985, 1979, 1972. That looks correct. All right, so let me scroll to the bottom there and get that ready. Okay, next I need to actually figure out the value of my state variable, inflow, high, and rising. Remember what the definition was. It needs to be above 2200 CFS and rising for the previous 4 hours. So I'm just going to start by saying value, and I'm going to initialize it as 0, and it has to meet certain qualifications, in which case I'll change it to a 1, and then I'll print out that value down here. All right, so the first one was, it has to be above 2200 CFS. Let's address that first. So I'll just say if inflow is less than or equal to 2200, then value equals 0. And then LF has been rising for the past 4 hours. It's not possible to have been rising for the past 4 hours if it's within the first 3 hours. So what I'm going to do here is I'm going to say LF step is less than or equal to 5. And that's also going to be value equals 0. And then else, now I need to check the previous steps. Okay, I'm going to create a new variable and just call it flow increasing last 4 steps. And then I'm going to say that it is a 1. And then I'm going to loop for I in range step -4 and then step by -1. colon. Okay, so that would be, it would start at 6. So, for example, if step equals 6, then I would be 6, 5, 4, and 3. Then I want to create an index for the previous step. So I'll just say I prev equals I minus 1. Now I want to actually get the inflow value at that step and at the previous step. So that step would be I. The previous step would be I prev. Inflow, this equals inflow time series. And then I want to get the value. Here's the value. Hold on. Yes, get value right here. And then this int, I believe, is the step number, but we can confirm that by clicking on time series here and then F1 and then looking up the get value method definition. So let me just make this a little larger. Okay, so we're looking for get value. These are alphabetical, I believe. A lot of getters. Get value int step. This is the one. Get the value at the step. Yep. Okay, that's good. I don't need that anymore. So we can just write in step. And the step here is going to be I. And then let's get the previous inflow. So we'll call it inflow prev equals inflow time series dot get value I prev. Okay. All right. So now we have those two inflows. Now we'll do an if statement. If inflow this is less than or equal to inflow previous, then the condition is not met. Then the flow increasing last 4 steps is going to be set to 0. Okay. Okay. But then if it is true, if it is 1 for all 4 steps that we test, then I can come outside the for loop and say, do an if equals 1, and then that would make my value equal to 1. All right. So we have the value starts at 0, and if it meets all these conditions, then it is 1. That's the value we're going to write to our state variable, the inflow high and rising binary variable. We can just actually add this value to our output if we wanted to like check it in the console log one more time. Just copy and then paste, and then save. Yeah, I don't want to do that though. I know it's right. Or I mean, if it's not, I can check it. So let's just forge ahead. The last thing we need to do is actually set the value. So I will set value, and then the time series that we're going to reference is itself because we're writing this Jython script inside the inflow high and rising binary script here. It gives us this current variable reference, and we're going to just put that right there, and then dot, and I need to set the variable, set the value, a state variable, set value. I believe this is it right here. And then I need to set the time step. So that's going to be current runtime step. We've used this already a few times right there. Okay. And then double, that's just going to be the value 0 or 1, which is true or false, essentially. But I just chose to go with an integer here because I thought that'd be a little safer. I'm not sure if like a Boolean variable would be supported or not. So just going to go with that and see what happens. All right. So compile script. Oh, problem. Line row 26. Something's up. Okay. So I need to, forgot an equal sign. Let's compile again. Okay. Successful. Let's go ahead and save that. What we're going to do is we're going to run the compute one more time, and then we're going to look at this inflow high and rising binary data set, which should be part C in the DSS file that's computed and written to during the simulation. Again, this is alternative 1, trial 1. So let's move this out of the way and then right click compute. Okay, so that was good, nice and quick. And then now let's go up to tools, HEC DSS view, simulation 1. Okay, so I'm in the correct file here. Now for part C, I'm going to scroll down to my inflow high and rising binary. And then here's the record here. And then here are the values. Great. Looks like it worked. So here, yeah, so there's a couple ones. That's great. Mostly zeros as I expected it to be. And then let's take a look at the plot. All right, cool. So here's the plot, and we have, it looks like mostly zeros, but there are a few times during the month of July that our time series did satisfy those conditions about being high and rising. What I want to do is just take a look and confirm that that data matched up with the inflow, just a visual inspection. So what I'm going to do is I'll click on flow, And let's see, we want flow to CP2 or CP1. It's the same thing. It's null routing. And then alternative one. What I'm going to do is I'm going to right click and duplicate and just rename part F to something that's unique I can filter by. I'll just say custom one and then tab off. Okay. So a duplicate record has been created. That's that. Now let me go ahead and go to the inflow high and rising state variable. And then I'm going to create a duplicate of that. And then I'll call this custom one as well. I think it's case insensitive, so that's fine. All right, now let me clear that filter out and select the blank option. And then over here, I'll click custom one, and then I can highlight both of these records and then plot. And okay, well, they're on different axes, and that's all right. So we have the flow. This is the inflow. And then in the bottom plot, we have the state variable that is either 0 or 1. So right here, it's 1 for almost an entire day, which represents the time that, let's see, the flow was above 2200 and has been rising for at least 4 time steps, which is 4 hours. Looks like we have the same condition on almost all of July 9th, and then again for about a day between the 11th and 12th, and then 2 more times later in the month. And, without looking at the numbers, I could, but here are the numbers. We could confirm that, but I think the data looks pretty accurate. Let's do one more thing. Let's create a second state variable now since we have all this data set up. It will be a scriptless state variable, but I will write to it from the Jython script that we just created. And it will be the opposite situation where the flow is less than 1800 and has fallen for the previous 4 time periods. So I expect, I don't know if that would qualify, but I think we'd have hit here, definitely a hit here, and then probably 2 more at the very end of the month. So let's go ahead and do that and then return to this plot and call it good. All right, so we're going to go back to the state variable editor, which is right here. Okay, the first thing I want to do is just change the value, the variable value to value rising. So I won't get confused with value rising and value lowering. Value rising, and then value rising, value rising, value rising. And we have a few more down here. Value rising, value rising. Okay, did I miss any? Set value rising. All right, very good. Okay, so let's go ahead and save that. Now I'm going to create a new state variable. So we'll go state variable, new, and then I'm going to type in or paste in inflow low and lowering binary. And for a description, I'm going to say essentially the opposite of what I did last time when the inflow is below 1800 CFS and has been lowering for the past 4 hours. And I'll click OK. Up here at the parameter name, I will paste in the same name as what we had here. Inflow low and lowering binary. And then the parameter type, I will also say count. It's just going to be a 0 or 1. The main difference between this state variable is that it won't be a Jython script. I'll just say scriptless. Now I could call it a Jython script and write out the same code that I had on the previous main tab for our other state variable, which is an option, but I just wanted to kind of mix it up and try some different things. So we're going to go ahead and select scriptless, and I'm going to save that. And I don't need to do anything else with this inflow low and lowering binary state variable anymore. It's just static. It's just going to be written to and read from, but no actual Jython code associated with it. So let's go back to the inflow high and rising binary state variable. Here's our code as before. And we have the step is good, date time is good, the inflow time series, that's good. We'll keep all that. And then instead of value rising, I'm just going to copy all this and then come down here and paste and then modify it because there's only a few changes we actually have to make. Value rising, I'm going to change to value lowering. So there's value lowering. It's going to be initialized to 0. Now, if the inflow is greater than or equal to 1800 CFS, then it's 0. If the step is greater than or equal to 5, it's also 0. So that's true, doesn't need to be changed. Now we need to basically do the same thing as before, but instead of inflow this less than or equal to, it's going to be greater than or equal to. And then just to be, I mean, we could use the same variable here, but I'm going to change it so I don't get confused. Inflow lowering last 4 steps. This is certainly not the most concise way to minimize line count to perform this operation. I understand that. This is just one of our first examples, so just bear with me. So I'm going to copy, copy, and then this variable needs to be changed a couple more times. We can come down here and print it out as well. And then value lowering is going to be written not to the current variable. What we want to do here is reference our other state variable that we created, the inflow low and lowering binary. So this needs to go. I'm going to delete this. Let me just get a new line so I can see exactly what I'm going to bring in from the API tree here, and then I'll clean it up. We want to go to state variables, and this is inflow low and lowering. So double click. Okay, so this is the reference to that time series. So I'm just going to go dot, and then I can reuse the same code here of set the value and value lowering. All right, let's go ahead and give that a shot. Compile script. That's a good first step. Let's go ahead and save it. Okay, and let me move this to the side, and then right click, compute. Okay, I think I misspelled something. Yep. Okay, this is, I don't know how that got misspelled. This is just value rising. Okay, save. Okay, compile script. That says it's successful. Let's see what happens when we compute. So right click, compute. Oops, hold on. It was still open from the previous compute. And compute. Okay, so that looks good. Okay, let's go ahead and check out what that new state variable looks like. Make sure it has some data. HEC DSS view. And now we should have an inflow low and lowering. Here it is. And then let's go with a plot. Okay, we are our data. And we should see some ones. There's some ones right there. All right, so let's go ahead and also duplicate that and then make part F custom one and then see what all three look like together. Custom one. Okay. A duplicated time series data set has been created. Make clear that part C filter and then filter by custom one. Now we have all three of our variables here. And I didn't change anything, so the first two should be just as before. And here we have our plot. All right, so on the top we have our inflow. In the bottom, blue is that inflow high and rising for the past 4 hours. And then in red is where we have our inflow low and lowering for the past 4 hours. So this is all I plan to do for today's exercise for this video. There's nothing really fancy about this. You could probably do the same analysis in Excel in 10% of the time, but it's important to be able to know how to write this Python script, create these state variables, and then manipulate the code and write out to a DSS time series data set that can be used for analysis and simulation in HEC ResSim.